Yes, we will start the reaction with sodium metal. This is the reaction. This reaction is called as Wurtz reaction or Wurtz synthesis, in which the higher alkanes are formed. This reaction is asked for 2 marks for the board exam. Alkyl halides when reacts with sodium metal in presence of dry ether as the solvents, cross coupling and self coupling reactions takes place. I will explain with the help of reaction. One example, see here, twice Rx, 2 molecules of methyl, 2 molecules of alkyl halide we have to use plus twice Na, RR. This is coupling takes place and we get here twice NX. This X is removed and here coupling takes place. So this is a very specific reaction in which the higher alkanes are used. Higher alkanes are prepared by using lower alkyl halides. See, this one example is given here. Ethyl iodide, it is C2H5. This is ethyl iodide and we get the higher alkanes butane here. See, means the halide is lower and the alkane is higher. Butane is prepared. Coupling takes place here. This is C2H5 and this is C2H5. Twice Na, remove this twice iodines. We get here twice NaI, it is byproduct, and we get the coupling product. This is already explained in 11th standard, but in the 12th standard, one important reaction is there in this. If the two alkyl halides are different, then what will happen? We will see here. See, in this example, the one is a methyl bromide and one is a ethyl bromide now. The two alkyl halides are different. We get here 1, 2, 3, 4 products. We get 3 products, self-coupling and cross-coupling products. Self-coupling products are different and cross-coupling products are different here. CH3Br couples with CH3Br, we get here C2H6. C2H5Br couples with C2H5Br, we get C4H10. Means the self-coupling products are major products here. And the cross-coupling means this CH3 and C2H5 combines, we get C3H8. This is a minor product. So this is a cross-coupling and self-coupling reactions. This is a very important for the board exam. It is asked for 2 marks. This same alkyl halide reaction, it is already completed in 11th standard, but for the 12th standard, if 2 different alkyl halides are used, we get the 3 products here. Out of these 3 products, the cross-coupling products is minor and self-coupling products are the major. Remember these things, what is major and what is minor. Self-coupling wale jo products hai, that is a major, and cross-coupling wale jo products hai, that is minor products. We can take here any example. We can take ethyl chloride here. We can take butyl bromide here. Make a practice at your home. Take different examples and you can write the reactions. Then the reactions with haloarenes. Now, before this, you learn about the reactions of haloalkanes. Now the reactions with arenes means this is aromatic compounds. Wurtz Fittig reaction. Wurtz reaction is different and Wurtz Fittig reaction is different. Come to the example, then you will clearly understand. See, Wurtz reaction, you understand, in Wurtz reaction, alkyl halides and sodium metal is used. In also Wurtz Fittig reaction, sodium metal is used, but the alkyl halide and aryl halide is used. When alkyl halide and aryl halide is used, this reaction is called as Wurtz Fittig reaction. This reaction is called as Wurtz Fittig reaction. We get the product here, toluene. See how the toluene is prepared, because this twice Na removes this bromine and this bromine. Twice NaBr will be removed and this CH3 will be attached to the benzene ring. So this is a very good example of preparation of toluene by using Wurtz Fittig reaction. The question will be asked for the board exam. How will you prepare toluene? By using bromobenzene. Remember, we have to memorize this reaction is Wurtz Fittig reaction. They will give toluene, they will give bromobenzene plus twice Na only. They will give bromobenzene and twice Na. We have to add this CH3Br, or you can add CH3Cl, or you can add CH3INE. Halogen you can take here, except fluorine. So this is very interesting reaction, Wurtz Fittig reaction. Only the difference is one alkyl halide and one aryl halide is used. And the reaction conditions are same as Wurtz reaction. Sodium metal is there, dry ether is also there. Then next one is Fittig reaction. Wurtz Fittig is different and Fittig reaction is different. In case of Wurtz Fittig, one alkyl halide and one aryl halide is taken, and in Fittig reaction both the aryl halides are taken. Both the aryl halides are taken. See here one example I have shown here. Chlorobenzene, 2 molecules of chlorobenzene we have to take. Twice Na, we get biphenyl here. 2 molecules we have to take here. I forgot here to write 2 molecules of chlorobenzene. Coupling takes place and we get the biphenyl compound here. So today we learn about the Grignard reagent, Wurtz reaction, Wurtz Fittig reaction, and Fittig reaction. These 3 reactions are similar but quite change. In Wurtz Fittig, one alkyl halide, one aryl halide. In Fittig reaction, both the aryl halides are used. Then nucleophilic substitution reactions of haloarine. This is the last part of the chapter. Nucleophilic substitution reactions are slowest, very difficult to take place, because in case of alkyl halides, the bond between C and Cl is very weak. It can be easily broken. But in case of nucleophilic substitution reactions, they are less reactive, because I'm coming to that. There are many points which affects the reactivity. One by one, I will explain. First one is resonance effect. Such kind of resonance effect is absent in case of alkyl halides. Remember, such type of resonance effect is absent in case of alkyl halides, but in case of aryl halides, the resonance effect is there. See, the bond between this chlorine and this carbon is very strong. This cannot be easily removed. So that's why it is difficult to replace this chlorine. Nucleophilic substitution reaction means we have to replace this halogens from the aryl halides, and it is very difficult to break, because resonance takes place and the bond become very strong. This is due to the resonance effect. The second reason is difference in hybridization. See, I will explain. In case of alkyl halides, see, this is alkyl halide. In case of this alkyl halides, the hybridization is sp3, and in case of aryl halides, the hybridization is sp2. Because of this hybridization, what is happening? The bond length of this CCl, bond length in case of alkyl halides is 177 picometer, and in case of haloarenes it is 169. Means if the bond length is more, the bond is very weaker and we can be easily broken. If the bond length is very short, very small, the bond become very strong and it is very difficult to broken. Don't remember the reasons, because it is not asked for board exam, but you should know why this bond become very strong. There are different reasons. First reason is resonance. Second one is hybridization. Third reason is instability of the phenyl cation. Means when the phenyl cation will be prepared, if this X is removed, the cation is not stabilized by the resonance. So SN1 mechanism is ruled out, and backside attack of the nucleophile is blocked by the aromatic ring. That's why SN2 mechanism is also not possible. But these reactions are happen in case of specific conditions. In case of specific conditions, these reactions are happening when electron withdrawing groups are attached to the ortho or para position. See, directly I am coming to the examples of these nucleophilic substitution reactions. This is a chlorobenzene and NaOH. See, the temperature is very high, 620 degrees Kelvin and 30 atmosphere. These are the specific conditions we have to use. At this conditions, this chlorine is removed and we get the phenol. Chlorobenzene to phenol. This is a very good reaction. NaOH in presence of 623 and 300 atmospheric pressure, we get This phenol means this chlorine is substituted. This is an example of nucleophilic substitution reaction. And which is nucleophile in this reaction? Nucleophile is OH minus. It is substituted. These reactions are favorable when electron withdrawing groups are attached to the ortho or para position. See these examples. See in this example, chlorobenzene, this is nitrochlorobenzene. नाइट्रो ग्रुप इज इलेक्ट्रॉन विड्रॉइंग ग्रुप. नाइट्रो ग्रुप क्या करता है कि ये इलेक्ट्रॉन डेंसिटी बेंजीन के अपनी तरफ खींचता है. सो दिस बॉन्ड बिकम वेरी वीक एंड वी कैन इजीली रिमूव दिस क्लोरीन. सो जितने ज्यादा NO2 ग्रुप्स रहेंगे उतने इजी होगा ये बॉन्ड ब्रेक करने के लिए. कौन सा बॉन्ड? द बॉन्ड बिटवीन द Cl and this carbon. See here in this reaction there are two NO2 groups are there. So two NO2 groups, see the temperature is very less required. Here is only one NO2 group, see the temperature is 443. And see here there is no any NO2 group, see the temperature is 623. Means अगर इलेक्ट्रॉन विड्रॉइंग ग्रुप अगर हमने अटैच नहीं किया है तो टेम्परेचर ज्यादा लगेगा ये क्लोरीन रिमूव करने के लिए. तो इस एग्जांपल में आप देख सकते हैं क्लियर कट NO2 ग्रुप इज देयर. एक NO2 ग्रुप है तो न्यूक्लियोफाइल सब्स्टिट्यूट करने के लिए 443 की जरूरत है. यहाँ पे 2 NO2 ग्रुप से सी द टेम्परेचर इज 368. कम टेम्परेचर में ये रिप्लेस होगा. अगर हमने 3 NO2 ग्रुप यहाँ पे अटैच किए तो देखो ओनली हीट करने के बाद ये न्यूक्लियोफाइल सब्स्टिट्यूट होगा. मीन्स आपको समझ में आना चाहिए कि जितने ज्यादा हम इलेक्ट्रॉन विड्रॉइंग ग्रुप यहाँ पे अटैच करेंगे तो उतना इजी होगा कि ये क्लोरीन हमको रिमूव करना है. क्लोरीन यानी ये नहीं अपना कौन सा ग्रुप, ये हेलोजन रिमूव करने के लिए आपने को इजी होगा. So one question is written here: conversion of chlorobenzene to phenol by aqueous solution of sodium hydroxide requires higher temperature, about 623 Kelvin, and high pressure. Explain. ये reaction के ऊपर question नहीं. What is the question? कि क्लोरोबेंजीन टू फिनॉल बनाने के लिए 623 टेम्परेचर की जरूरत क्या है? उसका सिंपल रीजन है बिकॉज देयर इज नो एनी इलेक्ट्रॉन विड्रॉइंग ग्रुप इज अटैच्ड, सो द टेम्परेचर रिक्वायर्ड इज वेरी हाई. अगर हमने ज्यादा से ज्यादा 3 इलेक्ट्रॉन विड्रॉइंग ग्रुप यहाँ पे अटैच किए तो टेम्परेचर कुछ भी टेम्परेचर की जरूरत नहीं है. जस्ट वार्म वाटर यूज करने के बाद अपने को ये प्रोडक्ट मिल सकता है. So this is the difference between nucleophilic substitution reactions of alkyl halides and aryl halides. The last part of this chapter is electrophilic substitution reactions. Electrophilic substitution reactions, electrophiles are positively charged species. These reactions also already studied in case of 11th standard. Halogenation means addition of halogen. See, this chlorobenzene is ortho-para directing group. This is ortho, 1, 2 position is ortho and 1, 4 position is para. So we get the 2 products in the reaction. This is major and this is minor because there is no any steric hindrance is there. This 1, 2, it may be steric hindrance is there. So it is minor and this is major. In all the reactions, we get the 2 products here. Nitration, matlab ye introduction of NO2 group. This is a minor, this is major because there is no any steric hindrance. This is 1, 4 position. This is also 1, 4 is major. Nitration means introduction of NO2 group. In 11th standard, we already studied what is mean by nitration. Nitration mixture is used. Nitration mixture means the mixture of concentrated HNO3 and concentrated H2 super is used. We get here NO2 group. NO2 group is attached at ortho and para position. Then in case of sulfonation, SO3H group is attached. Again, this is a minor, this is major. The reasons are same. No any steric hindrance is there. SO3H group is attached in case of sulfonation. Nitration NO2 group is attached. Halogenation halogen is attached. And the next one is Friedel-Crafts reactions. In 11th standard also we studied there are 2 types of Friedel-Crafts reactions. One is alkylation and one is acylation. Again, I am going to explain these 2 reactions in details. When CH3Cl is used, this is alkyl halide. This reaction is alkylation. And when acyl chloride is used, CH3COCl, this is Friedel-Crafts of acylation. Alkyl chloride is used, this is a Friedel-Crafts alkylation. And if acyl chloride is used, this is called as Friedel-Crafts acylation. In this CH3 plus is electrophile. In this CH3CO plus is electrophile. Nitration, NO2 plus is electrophile. Sulfonation, SO3H is electrophile. In case of this halogenation, Cl plus is electrophile. NO2 plus is electrophile here. Sulfonation, SO3H plus is electrophile. And in case of Friedel-Crafts reaction, CH3 plus is electrophile here, and CH3CO plus is electrophile. All these nitration, sulfonation, halogenation, Friedel-Crafts alkylation, acylation, these are electrophilic substitution reactions. Don't get confused between electrophilic substitution and nucleophilic substitution reactions. Electrophiles यानी positively charged bases and nucleophiles यानी negatively charged bases. Negatively charged bases यानी OH minus is there, NH2 minus is there. Then we already seen these nucleophilic substitution reactions in that preparation of alcohols, then preparation of amines, Williamson synthesis. In Williamson synthesis, RO, that is alkoxides, are the nucleophiles. Then in case of esters, RCO, these are the nucleophiles. So today, it is your duty to revise all these reactions. What is meant by nucleophilic substitution reactions? What is meant by electrophilic substitutions reactions? Write this reaction at least 3 times. Friedel-Crafts reaction, nitration, then word synthesis, what is Grignard reagent, what is optical activity. These are the very important points in this chapter. This chapter having the 7 marks weightage, remember. If you prepare this only one chapter, you will get passed in the board exam. You understand? If you got 7 out of 7 marks, and in practical, if you got 28 marks, 28 plus 7, 28, 29, 30, 31, 32, 33, 34, 35. If you prepare one chapter carefully, you will be passed in board exam. Remember this, my statement. एक अगर चैप्टर आपने क्लियर कट किया तो आप बोर्ड एग्जाम में पास हो सकते हैं. इतना इजी है, केमिस्ट्री का टेंशन लेने की जरूरत नहीं है आप. So this part is removed for this year. Make a note there, environmental effects and uses. This is not included for this board exam for this year only. So this chapter is completed. This chapter is completed here. If you have any doubts, you can call me, you can message me, you can mail me. I will give the answers. So have a good day. I'm going to end this meeting now.